Hey everyone, and welcome to part 1 of episode 3 of the Gearx Mk1 Systems Introduction series. This will be a two-part series where we'll be covering the most interesting and most difficult system of all Gearx systems, the Gearx Magnetic Drive. Let's get stuck in right away. Let's hit it. This episode has been a long time coming, partly because there were delays with the delivery of our new camera. Yes, I'm coming to you in 4K now. I also took a short break from Mk1 development to pump out the initial designs for the Gearx portable lab. I wanted to present this video in a format where you'll be introduced to magnetic drive technology at a rudimentary level. I'll also be explaining my plans for development. It is absolutely possible that collaboration with some of the individuals and companies that you'll be introduced to in this video will be necessary in order for the Gearx Mk1 drive system to fully realize its potential. I may be wrong, at least I hope I am, but I believe that being open to collaboration is a key component in building a community around a technology in its infant stage in order to enhance its chances of success. Now for a quick overview of this episode. This will be a two-part series simply because there is too much to cover in just one video. To kick off part 1, we'll be going over 4 individuals and companies who are invested in magnetic technology and who partly inspired the formation of Gearx. This includes where they're at, what their advantages and disadvantages are, and their potential for collaboration. In part 2, we'll take a look at the Gearx Mk1 magnetic drive system, what inspired its design, where it's at, and how I'm going to tackle development in the short to medium term. I've arranged the following introductions of companies and individuals invested in magnetic tech in order of collaborative relevance, starting with who I believe to be most relevant. So ladies and gentlemen, allow me to introduce you to Andre and Sean from Infinityserve.com. These pair are Russian born and based in Seoul, South Korea. Their magnetic generator design boasts impressive specs, available in 5 and 10 kilowatt versions, and produces this output autonomously after being plugged in to 110 or 220 volt main supply for a short period of time. So what drives this generator, and why are Infinityserve.com at the top of my collaboration list? There are several reasons. For example, their magnetic generator design uses an ingenious combination of 3 things. These are bifilar coils, software, and a microcontroller. The term bifilar describes a coil that uses 2 materials, for example copper and steel, that are wound together to form the windings of the coil. These coils can perform 2 functions simultaneously when the circuit is closed and either a magnetic field passes by it or a small electric charge is put through it. So, how are Infinityserve.com converting magnetic force into electromotive force? According to their website, and transcribed for your convenience, their coil design combined with their microcontroller and software and a cylinder of individual magnets are producing enough residual back EMF which is captured and converted into electrical output. The bifilar coils themselves have 3 modes. Induction mode, where a charge is being produced, neutral mode, where the coil is not active, and electromagnet mode, where a charge is sent through the coil to turn it into an electric magnet for a short period of time. It would appear that they're using a sequential system of push and pull, catch and release, while using changes in EMF and back EMF to attain enough surplus charge to power electronic devices. This is the best I can offer in terms of deducing how their system works, and I'm completely open to being corrected if needed. There is one glaring drawback to their design, however, which is the requirement of their generator needing to be plugged in initially to a power supply in order for it to work. This limits the design's portability, which is one of the chief goals our Gearx design tries to overcome. Next on my list in terms of collaborative relevance, introducing Induction Energy. This company is based in Cheyenne, Wyoming, USA, and they built an industrial application of magnetic drive technology in the form of a generator dubbed the Earth Engine. It was designed and built under consultation with the help of Dennis M. Danzig. This particular design being shown compared to Infinityserve's magnetic generator design. Physically, it has a much larger footprint. It's also unclear what methods of flux field manipulation or induction methods are being applied to spin up these massive flywheels you're seeing here in their design. In my opinion, although the array of kinetic potential losses through a complex mechanical design such as this make it a rather peculiar beast, however, it is important to be able to showcase as many different designs for magnetic tech in order to appreciate what is happening here, which is the formation of a family of new technologies which is pretty cool. Next on my list in terms of collaborative relevance takes us back to where magnetic technology first began, which is with magnetic motors. Howard R. Johnson is the grandfather of magnetic technology, and he passed away in 2008. At the time of his passing, he was the holder of some 45 patents, ranging from chemistry to engineering. His patent for his first magnetic motor took 6 years to be awarded, due to the stringent laws surrounding anything deemed remotely perpetual. I say remotely perpetual because yes, magnets do indeed have a shelf and service life, which to me should be a sufficient basis for magnetic motors and generators to be excluded from being potentially classified as type 1 or type 2 perpetual devices, and is further evidence to me of our lack of depth of understanding for magnetic material, although we are able to apply them in some seriously advanced ways. We'll be coming back to take a closer look at Howard Johnson's research in further detail in part 2 as we go over the Gearx Mk1 Drive system, which is based upon his research. Lastly, my fourth collaboration candidate for a potential alternative magnetic drive system for your consideration, Muammer Yildiz and his magnetic motor. This particular design was at the top of my collaboration list due to the fact it was validated at Eindhoven and Delft University's faculties of engineering, as well as its compact and simple design. However, since it stepped on the stage in 2008, any further information on its development or commercial success has been remarkably limited. I can only speculate why this is the case, but I suspect it is a combination of right idea, right place, right time, wrong associates, poor market execution, or any combination of these factors reversed. One thing I've learned about entrepreneurship is that 100% of everything often leads to 100% of nothing. This is why the Gearx Mk1 is an open design and will always remain free. Even the greatest of ideas, under the greatest of motivations, pop in and out of existence if you fail to execute them the right way. So that about wraps up part 1 of episode 3 of the Gearx Mk1 Systems Introduction video series. If you have any questions or comments, drop them in the comment section below. Hit a like button or share this with your friends. Thank you for watching, and I'll catch you in the next one. Hey everyone, and welcome back to part 2 of episode 3 of the Gearx Mk1 Systems Introduction video series. In this video, we'll take a closer look at the Gearx Mk1 magnetic drive design, what inspired it, where it's at, and the way forward for development. Let's get stuck in right away. Let's hit it. Welcome back. In part 1, I introduced you to a small group of individuals and companies who are currently engaged in magnetic drive technology. And these examples could be pathways for future collaboration of Gearx magnetic drive development. In this group, I mentioned the grandfather of magnetic drive technology, Howard R. Johnson, whose research is the basis for the Gearx Mk1 magnetic drive system. The reason why I listed his design as an avenue for potential collaboration, although he is no longer with us, is because I currently only have limited access to his research. If that were to change, it would enable myself and others to speed up development of the Gearx Mk1 magnetic drive. I can't speak for Howard, but one would only hope that he would want this. Who wouldn't? So what have I learned so far from what I've had access to? 3 profound observations stuck out the most. Firstly, he and his close associate and friend, Tom Bearden, used an early CNC machine with a Gauss meter attached to its toolhead. They used this machine incrementally to map the flux field strengths of upright dipole magnets. They then took this data and used it to create a relief map, vector graph, which looks similar to a topograph. What they discovered is, in my opinion, remarkable. Both north and south poles are simultaneously present at each magnetic pole. However, they are just present in different strengths. This means that the standard model that were all shown at primary school with iron filings or grass seeds show us an incomplete picture of magnetic fields being produced by dipole magnets. And that's not all. What I also found to be profound from reading Howard's research is by compressing a major magnetic flux field at one pole of a magnet, you inadvertently strengthen the field at the opposing pole. Think of this like squeezing a water balloon at one end, where the pressure expands the balloon at the opposite end. This is the basis for understanding the shaping of flux fields, which is essentially the physical function of a Hohlbach array. We're not going to go into depth with Hohlbach arrays today, but suffice it to say they are a great way for packing complex flux fields into small or confined spaces. The next item that stuck out to me in Howard's research was his dipole arc magnet design. This, combined with his linear magnetic propulsion designs, which one could argue are primitive Hohlbach arrays, I found this to be a good starting point for a design for the Gearx Mk1 magnetic drive system. Many of the specifics of his research are unclear, which have produced inconclusive results for myself up until now, but one thing is certain. If his design for magnetic linear propulsion was successful, then wrapping it into a loop is also possible. In a previous episode, I mentioned that I had custom-made arc magnets made by a friendly company in Taiwan called greatmagtech.com. I applied my iteration to Howard's arc magnet design, together with the first iteration of the Mk1 control drawer, as a simple magnetic array to test the behavior of these magnets. I started out with just a simple semicircular array using strong cube magnets, arranged in a way that I believed would produce some linear momentum. Although this design is more of a placeholder than a design that was expected to succeed, it allowed me to take a closer look at the behavior of these arc magnets, and I was still pleasantly surprised with the results. The amount of magnetic cohesion that was present was remarkably low, and I found this to be a great starting point to further test drive jaw and control ring arrays. My plan is to continue to test the system in different configurations by accelerating it with compressed air and timing the duration until it stops. I'll be doing this repeatedly while swapping out designs and configurations, which is a bit like a game of hot or cold. This method also gives me the ability to make quick changes on the fly and the ability to backtrack whenever it's necessary. I'll also be documenting my findings along the way. However, this may take months or even years to exhaust some designs, which is why we need developers to get on board and to start their search with their own designs in their own way. Systems as ambiguous as these have the potential to stall development indefinitely, which is why the generator component design of Gearx has to take top priority. You should always do what you can do first, and is also one of the reasons why the Gearx Mk1 drive system for myself takes the lowest priority. You can choose a different set of priorities if you want to become a Gearx Mk1 developer, and that's totally up to you to decide. An important, in fact crucial, key factor to consider is to make any positive result replicable, otherwise we'll achieve very little. There is also an important milestone that stands in the way, which I touched on in previous videos, the frictionless magnetic coupling. If you wish to charge on without this design feature, please feel free. However, it will mean that you will end up with mechanical friction between the stator and rotor, which may or may not be the difference in energy or efficiency between success and failure, simply because we don't know how much free energy we will be able to capture with this design in its current state. Also, something worth consideration, Gearx needs to be service free, which makes the frictionless magnetic coupling a high priority from a first principles standpoint. For now, it will be my number one focus until it is achieved, and we're already halfway there with the Z-axis control dialed in. It would be a waste to abandon such a cool and crucial feature partway through its development. So, this was the third and final episode of the Gearx Mk1 Systems Introduction video series. The series was a lot of fun to make. I learned a lot, but it was also very time consuming, and I want to thank you for your patience and support. From here on out, you'll see a little bit less video content from me so that I can focus more on Mk1 development, but I'll continue to share regular updates with test videos. Once the generator portion of the Mk1 design is complete, I'll make a how-to series for the full Mk1 assembly. Please bear in mind that I have other commitments too, which not only include keeping a roof over my head and food on the table, as well as accelerating the world's transition to sustainable energy, but I'm fully committed to seeing the Gearx Mk1 in operation and in a vehicle platform in the near future, and ultimately sending Gearx to Mars as soon as it is possible. So that about wraps it up, guys. Thank you for watching, and I'll catch you in the next one.